Continuous probability distributions, Chapter 7. In this chapter, we will continue studying probability distribution by examining a continuous probability distribution. We will learn about the normal probability distribution, which is the most important continuous probability distribution. It has many real-life applications. Learning objectives. We will take section 7.2 and 7.3. 7.2. Describe the characteristic of a normal probability distribution. Section 3. Describe the standard normal probability distribution and use it to calculate probabilities. Normal probability distribution. The normal probability distribution is a continuous distribution with the following characteristics. It is bell-shaped and has a single peak at the center of the distribution. The distribution is symmetric. It is asymptotic, meaning the curve approaches but never touches the x-axis. It is completely described by its mean, which is mu, and standard deviation, which is sigma. The normal probability distribution has a complex formula to find the probability, but we will not need to use it. Instead, we use the table given in Appendix B3. There is a family of normal probability distributions. Another normal probability distribution is created when either the mean or the standard deviation changes. Here is a graphical display of the characteristic of the normal distribution. The location of a normal distribution is determined by the mean, which is in the center of the bell-shaped curve. The spread of the distribution is determined by the standard deviation. The area under the curve defines the probabilities. Also, the total area under the curve is equal to 1. So, the area to the left of the mean is 0.5 and the area to the right of the mean is 0.5. Family of normal probability distributions. There is not just one normal probability distribution, but a family of them. In the top left graph of employee service at 3 different plants, the mean is the same, that is, they have the same mean, but the standard deviations are different. The top right chart of tensile length of 3 different cables, they have different means and different standard deviations. In the bottom graph of box weights of 3 different cereals, the means are different and the standard deviations are the same. So for the last graph, there is different means and equal standard deviation. Standard normal probability distribution. The number of normal distribution is unlimited, but they can all be converted to a standard normal probability distribution. The standard normal probability distribution is a particular normal distribution. This standard normal probability distribution has a mean of 0 and a standard deviation of 1. The z-value, the sign distance between a selected value designated x and the mean mu divided by the standard deviation. So any normal probability distribution can be converted to the standard normal probability distribution with the following formula: z equal x minus mu divided by sigma, where mu is the mean or the expected value and sigma is the standard deviation. Areas under the normal curve. Keep in your mind that is, the total area under the curve is 1. Here is a portion of the Z table. For example, if you have Z equal 1.5, this reflects an area or probability of 0.4332. How we find it? First start with the value of Z equal 1.5. Then move horizontally under 0, 0, you will get the answer, which is 0.4332. Suppose you have the Z value is 1.52. So start with the value of Z, move down until you reach 1.5, then move horizontally under 0.02. So the Z value, which is 1.52, has an area of 0.4357. Example, standard normal probability example. In recent years, a new type of taxi service has evolved in more than 300 cities worldwide, where the customer is connected directly with a driver via a smartphone. It uses the Uber mobile app, which allows customers with a smartphone to submit a trip request, which is then routed to Uber driver, who picks up the customer and takes the customer to the desired location. No cash is involved. The payment for the transaction is handled via a digital payment. Suppose the weekly income of Uber driver follows the normal probability distribution with a mean of $1,000 and a standard deviation of $100. What is the Z value of income for a driver who earns $1,100? We want to find a Z value. Use the definition of Z value. Z value equal x minus mu divided by sigma, where mu is 1000 and sigma is 100. X is $1,100. So substitute in the formula of Z. So 1,100 minus 1,000 divided by 100. So answer is 1. So the Z value is 1. Next, what is the Z value of income for a driver who earns $900? Use the formula Z equal x minus mu divided by sigma, where mu is 1000 and sigma is 100, or x is 900. Z equal 900 minus 1000 divided by 100, which is minus 1. Regardless of whether Z is plus or minus, the area under the curve is 0.3413, because we will use symmetry of the curve. Interpretation and uses of the standard deviation. The empirical rule. For a symmetrical bell-shaped frequency distribution, approximately 68% of the observations will lie within plus and minus 1 standard deviation of the mean. This means that about 68% of the observations will lie within mu minus sigma and mu plus sigma. About 95% of the observations will lie within plus or minus 2 standard deviations of the mean. It means that about 95% of the observations will lie within mu minus 2 times sigma and mu plus 2 times sigma. And practically all 99.7% will lie within 3 standard deviation of the mean. It means that about 99.7% will lie within mu minus 3 times sigma and mu plus 3 times sigma. Refer to the below graph. This graph has standard deviation equal 10, and mean equal 100. A symmetrical bell-shaped curve showing the relationship between the standard deviation and the percentage of observations. About 68 of the values between mu minus sigma and mu plus sigma, that is between 100 minus 10 and 100 plus 10. It means that about 68% of the values between 90 and 110. About 95% of the values between mu minus 2 times sigma and mu plus 2 times sigma. That is 100 minus 20 and 100 plus 20. So about 95% of the values between 80 and 100. Finally, 99.7% of the observations are between mu minus 3 times sigma and mu plus 3 times sigma. That is between 100 minus 3 times 10 and 100 plus 3 times 10. That is between 70 and 130. The empirical rule. To verify the empirical rule, use the table in Appendix B3 to find a Z of 1. This corresponds to 0.3413. So plus and minus 1 standard deviation is 0.3413 times 2, which is 0.6826. Write the answer as a percentage and round, so it's about 68% of the observations. A Z of 2 corresponds to 0.4772, so plus or minus 2 standard deviation, so 2 times 0.4772 equal 0.9544. Write this answer as a percentage and round. So this is 95, it's about 95%. A Z of 3 corresponds to area of 0.4987. So plus or minus 3 standard deviation, 2 times 0.4987, which is 99.7%. The empirical rule example. As part of its quality assurance program, the Autolite Battery Company conducts tests on battery life for a particular diesel alkaline battery. The mean life is 19 hours. The useful life of the battery follows a normal distribution with a standard deviation of 1.2 hours. Question 1. About 68% of the batteries failed between what two values? We want to find a range of 68% of the batteries failed. So, it's a range of 68% is mu minus sigma and mu plus sigma. That is between 19 minus 1.2 and 19 plus 1.2 hours. About 68% of batteries will fail between 17.8 and 20.2 hours. Question 2. About 95% of the batteries fail between what two values? We want a range of 95%. A range of 95% is mu minus 2 times sigma and mu plus 2 times sigma. That is 19 minus 2 times 1.2 and 19 plus 2 times 1.2 hours. So about 95% of batteries will fail between 16.6 and 21.4 hours. Virtually all of the batteries fail between what two values? We want to find a range of 99.7%. A range is mu minus 3 times sigma and mu plus 3 times sigma. That is 19 minus 3 times 1.2 and 19 plus 3 times 1.2 hours. Practically, all of the batteries will fail between 15.4 and 22.6 hours. Finding areas under the normal curve. What is the Z value of income for a driver who earns $1,100? To find Z, we use its formula. Z equal X minus mu divided by sigma. Equal, substitute for X equal $1,100 minus mu, which is 1,000, divided by sigma, which is 100. Use your calculator, answer is 1. Now to find the area from Z equal 1 up to Z equal 0, we use a table. First, start with Z, with the value of Z, which is move down, see the column of Z, move down until you reach 1. Then move horizontally under 0.00. So the area between Z equals 0 and 1 is 0.3413. If we want to find the probability that the weekly income is less than 1,100, this is the same as the probability of Z less than 1. To find the probability of Z less than 1, this is equal to the area to the left of Z equal 1. This area divided into two parts. The first part, the area between Z equal 0 and Z equal 1, plus the area to the left of Z equal 0, which is always half or 0.5. So the probability of a weekly income less than 1,100 is equal to the probability of Z less than 1, which is equal to 0.3413, this is the area from Z equal 1 to 0, plus 0.5, which is the area to the left of 0, to the left of Z equal 0, which is half. So the probability for a weekly income less than 1,100 equal the probability of Z less than 1, which is 0.8413. Finding areas under the normal curve. What is the Z value of income for a driver who earns $790? Start with the formula of Z. Z equal X minus mu divided by sigma. Substitute for the values. This is equal $790 minus $1,000 divided by $100, which is minus 2.1. If you want to find the area from Z equal 0 to Z equal minus 2.1, you have to refer to a table of Z distribution. Note that the area between Z equal 0 and Z equal 2.1 is the same as the area between Z equal 0 and Z equal minus 2.1. Now we want to find the area from Z equal 0 to Z equal minus 2.1. We will refer to a table. First, start with a column with Z. Search for 2.1. Then move horizontally under 0.00. So answer is 0.4821. So area from Z equal 0 up to Z equal minus 2.1 is 0.4821. Suppose we want to find the probability that the weekly income is less than $790. First step, find the Z value. the Z value from above is minus 2.1. So the probability of the weekly income less than 790 equal the probability of Z less than minus 2.1. This is equal الarea to the left of Z equals 0 minus الarea between Z equals 0 and Z equal minus 2.1, which is 0.5 minus 0.4821, which is equal to 0.0179. So the probability that the weekly income less than 790 is 0.0179. Finding areas under the normal curve. What is the Z value of income of a driver who earns $840? We use Z equal X minus mu divided by sigma, which is 840 minus 1000 divided by 100, which is equal to minus 1.6. What is the Z value of income for a driver who earns $1,200? We will use the corresponding Z value for the weekly income, which is equal to 1,200. Z equal X minus mu divided by sigma equal $1,200 minus $1,000 divided by $100 equal 2. Suppose we want to find the probability that the weekly income is between $840 and $1,200. To solve this question, we start with finding the Z value for the weekly income equal $840 and the Z value for the weekly income equal $1,200. From above, we know that Z1, which is corresponding to 840, is equal to minus 1.06, and Z2, which is corresponding to 1,200, is 2. So the weekly income, the probability of the weekly income between 840 and 1,200 is the same as the probability of Z between minus 1.06 and 2. Refer to the given graph. We combine two areas, one area to the right of the mean, which is Z equals 0, and one area to the left of the mean. So this is equal to the area between Z equals 0 and Z equal minus 1.6 plus the area between Z equals 0 and Z equal 2. Use a table to find the area from Z equals 0 to 1.6, and use a table to find the area from Z equals 0 up to Z equal 2. So we'll answer from the table 0.4452 plus 0.4722, which is equal 0.9224. So the probability of a weekly income between $840 and $1,200 is 0.9224. Finding areas under the normal curve. What is the Z value of income for a driver who earns $1,250? Start with formula of Z. Z equal X minus mu divided by sigma. Substitute for the values. So we have 1,250 minus 1,000 divided by 100. Answer is 2.5. What is the Z value of income of a driver who earns $1,150? Z equal X minus mu divided by sigma equal 1,150 minus 1,000 divided by 100, which is 1.5. Now, find the probability that the weekly income is between $1,150 and $1,250. To solve this question, or to find the probability, first step, Find the Z value, which is corresponding to $1,150, and find the Z value corresponding to $1,250. So the weekly income, the probability of the weekly income between 1,150 and 1,250 equal to the probability of Z between 1.5 and 2.5. Refer to the given graph. We find the area of two values on the same side of the mean. So subtract the smaller area from the larger. This is equal to area between Z equals 0 and Z equal 2.5 minus area between Z equals 0 and Z equal 1.5. Now use the Z table to find the values of the areas. This is equal to 0.4938 minus 0.4332, which is 0.0606. So the probability of a weekly income between 1,150 and 1,250 is 0.0606. Finding a value for X using Z. Lighton Tire and Rubber Company wishes to set a minimum mileage guarantee on its new MX100 tire. Tests reveal the mean mileage is 67,900 with a standard deviation of 2,050 miles, and that the distribution follows the normal distribution. Let X represent the minimum guaranteed mileage and use the formula for Z to solve so that no more than 4% of tires need to be replaced. We want to find the minimum guaranteed mileage. So use the formula for Z. Z equal X minus mu over divided by sigma, which is equal X minus 67,900 divided by 2,050. But this equation has two unknowns, Z and X. So we will start to find Z. So there are two unknowns in this equation, Z and X. To find X, we first find Z and then solve for X. From the characteristic of a normal curve, that the area to the left of mu is 0.5. So the area between mu and X is 0.5 minus 0.04, which is 0.46. Now refer to the Z table. Search the body of the table for the area closest to 0.4600. The closest area is 0.4599. Now move to the margins from this value and read the Z value of 1.75. Because the value is to the left of the mean, it is actually minus 1.75. So the Z value is minus 1.75. Now use this value in the formula. Minus 1.75 equal X minus 67,900 divided by 2,050. Solve this equation. The answer is X equals 64,312 miles. So the minimum guaranteed mileage should be set at 64,312 miles, so that only 4% of the tires will be replaced under this plan.